Okay, guys, today we're going to talk about the perimeters and areas of similar figures and their ratios. Um, and it boils down to this really quick. Actually, we'll start off, instead of filling this out, I'm going to draw two rectangles. I got a rectangle here, call this 4 and 3. I'm going to draw a similar rectangle here. Okay, similar rectangle here, 8 and 6. Okay, and so hopefully you notice that these two are going to be similar figures. They're both rectangles, meaning that their opposite sides are going to be the same, so they all have the same ratios and stuff. Okay, similarity ratio. Their similarity ratio, remember, we can find that by doing its corresponding sides over each other. So the similarity ratio between these two should be 1/2. Okay, we did the same thing with 3/6. Okay, you see that our similarity ratio between these two is 1/2. Alright. What I want to talk to you about today is finding the ratio of their areas and their perimeters. Okay. And so, in order to find the ratios of their areas and perimeters, we probably should just kind of look at their areas and perimeters. So, let's find the perimeter of both of these. Okay, the perimeter of this one should be 4 plus 4, 8, plus 3 plus 3, 6, 8 plus 6 is 14. The perimeter of our larger one is 16 plus 12, which is 28. When we find the ratio of their perimeters, well, you'll notice that that's 1/2 as well. And let's do the same thing with their area. Area ratios, or the ratio of their areas. Okay, the area of the smaller one is 4 times 3, which is 12, and the larger one is 48. Okay, so 12 over 48, which simplifies to 1/4. Okay. Alright, so this is a very simple example, but I want to use this as an example to show what our similarity ratios are between the perimeters and areas. Sorry, what our ratios are for similar figures for their perimeters and areas. So, let's fill in this and then we'll look at it over here again. If the similarity ratio of two similar figures is A over B, then the perimeter ratio, or the ratio of their perimeters, I'll just call it the perimeter ratio. Their perimeter ratio is also A over B. So notice here, if we call this A and B, if this was 1/2, this was also 1/2, A and B. Okay, so they're pretty much similarity ratio and the ratio of the perimeters is the same thing. It should be the same number. Okay, the ratio of their areas is going to be A squared over B squared. So here we wrote it as 1 over 4, but hopefully you notice it was 1 squared, which is 1, over 2 squared, which is 4. So A squared over B squared. Okay. So this is a very simple example, but hopefully you see that it is one that will work. And we'll look at that as we go through these examples down here today. Okay. Cool. Alright, so here we go. Let's go through a few examples. The trapezoids at the right are similar. These two are similar. What is the similarity ratio? Well, the similarity ratio we can find by putting the corresponding sides together in a fraction, so 6 over 9. These two sides correspond, and then simplifying it. 2/3. Their similarity ratio is 2 to 3, or 2/3. What's the ratio of the perimeters, or what is the perimeter ratio? The perimeter ratio is going to be, well, the same as their similarity ratio. We don't have to do any calculations for it. Once we figured out their similarity ratio, we know the perimeter ratio is the same thing. And their area ratio is going to be their similarity ratio squared. Okay, 2 squared is 4. 3 squared is 9. The ratio of their areas is 4/9. Alright, the area of the smaller regular pentagon is 30 centimeters squared. I'll write that inside. Okay, find the area of the larger regular pentagon. So here, these are regular pentagons. Regular meaning all the angles are the same. It's the same shape, different sizes. Okay? So we don't know what this is, I'm going to call it x. We're going to find this out by using the similarity ratio. In this case, our similarity ratio we can find by putting our corresponding parts and simplifying. So our similarity ratio should be 2 to 5. And then we're going to change that to find the ratio of the areas. So if our similarity ratio is 2 over 5, our ratio of our area should be 2 squared over 5 squared, or 4 over 25. Okay, so 4 over 25 should equal our small area over our large area. Cross multiply. 4x will equal 750. Okay, divide both sides by 4, and x will equal 187.5 centimeters squared. That should be the area of the large pentagon. Okay, so we had to find the ratio of areas, and then we had to use that in our proportion. Alright, look at example 3. Example 3 gives us a similarity ratio. They say it's 3 to 4. The area, key word here, the area of the larger decagon is 96 inches squared. So they gave us a similarity ratio, but that similarity ratio, we'll just use that to find the ratio of our areas. So again, that'll be 3 squared, which is 9, 4 squared, which is 16. They told us the area of the larger decagon was 96 inches squared. So I'm going to put 96 here. The smaller one with the smaller number. And now I'm going to cross multiply. I know I get 16x. 9 times 96, I think, was 864. Okay, divide both sides by 16. And I get this as 54. So x is 54. The area of the smaller decagon is 54 inches squared. Again, finding the similarity or the area ratio of the areas, and then using that ratio and a proportion to find the area, the missing area. All right, the area of two similar triangles is 50 centimeters squared and 98 centimeters squared. Okay, 50, 98. What is the similarity ratio? So now we're kind of working backwards from what the other two examples were asking us to do. We're going from these areas and then going into the similarity ratio. So what I'm going to do is I'm going to simplify this fraction, okay? Because I know this should be a squared to b squared. But I want to simplify this fraction because I want to get from a to b. So I know that 2 goes into both of these numbers. So 50 divided by 2 is 25. 98 divided by 2 is 49. Okay. So now I have a squared over b squared. Still the same thing because I'm just simplifying the fraction. I want to find a and b. These are perfect squares. It helps me out a lot. Makes it a little bit easier to do. So I have to take the square root of both of these to find a and b. Take the square root of 25, I get 5, and the square root of 49, I get 7. Okay, Something kind of tricky, kind of gets some people sometimes, is they're asking you for two things, or it might feel like they're asking for two things. But remember that both the similarity ratio and the area ratio is A over B. It means the same thing. Okay, so the answer for the similarity ratio is 5/7. The answer for the perimeter ratio is 5/7. Same thing. Alright, last one, example 5. Kind of the same thing here. Here of two similar parallelograms is 1,875 feet squared and 135 feet squared. Okay, find the ratio of their perimeters. Okay, well, again, I'm going to simplify these things because I'm going to have to take the square root. Okay, because I know that the ratio of their areas should be this. The ratio of their perimeters is going to be A over B. So I know I'm going to have to take the square root to get from here to here. But I want to simplify these numbers because taking the square root of smaller numbers is usually easier. So, let me bring up my handy dandy calculator. First, make sure that these numbers don't just go evenly into each other, and they don't. Okay. So 1,875 divided by 5 gives me 375. I'll divide the bottom by 5 as well, which gives me 27. I know that this simplifies by 3 because 3 plus 7 is 10, plus 5 is 15. Any number that adds to a number divisible by 3 is divisible by 3. Kind of a trick I picked up. 1, 2, 5. Once I divide that by 3. 27 divided by 3 is 9. Okay. So now I have 125 over 9. I know I can't simplify that any further. And so now I have to take the square root of both of these numbers. Square root of 9 is 3. Okay. Square root of 125, I'm going to just do this up here. It's 25 times 5. 5 is prime. 5 and 5. So I have a pair of 5s and a 5 left at home. So 5 radical 5 over 3 is A over B. And that is the ratio of their perimeters. Alright.